Thank you and good afternoon. So Steve Hagan and I were going to be presenting today. Steve Hagan unfortunately could not make it today, so I'm covering for him. My name is Kimon Onuma, and Steve and I have been involved with a lot of different organizations, the AIA, the Building Smart Alliance at the National Institute of Building Sciences, and this presentation actually was triggered from a presentation at AIA National a few months ago. It's about game changers, and we believe that architects can be game changers. It's really an opportunity that we all have sitting right in front of us. So we need to grab that and show what we can do with it. And the interesting thing, actually, I was yesterday in Washington, D.C., and we were talking about HBIM with an owner, with the State Department. They have a lot of existing buildings, and we're talking about how can we use BIM for historical buildings. So there's a huge amount of opportunities. It's an incredibly complex industry, but it's up to us to solve that. So in Game Changers, there was a series of presenters. I'm not going to go over all of them today, but we have an ongoing series of webinars about the Game Changers. And we even went back to 2005, this quote from Tom Maines that said, if you want to survive, you're going to change. If you don't, you're going to perish. It's as simple as that. Unfortunately, we're still kind of in the same place. We haven't really moved the needle far enough. And as an architect, that really concerns me. We've done some amazing work, but we really haven't shifted things enough. And if we don't, we are going to be overtaken. So, the architecture of building informed environments. This is an opportunity. Korean Airlines in 1983 strayed into Soviet airspace and was shot down. They basically lost their way, right? That same year, Reagan mandated the Department of Defense satellite systems be opened up to the public. This was a game changer. This is a technology that we all use today with our smartphones. We know where we are because this Department of Defense satellite system that used to be used for, still is used for defense, was opened up for us to use for the common good, to be able to find our way around the world. And our smartphones and smart devices now have shifted from what this used to look like this. They didn't work, they smelled bad, they didn't connect all the time. Then all of a sudden mobile devices came along. But this was a game changer, but the real game changer came here. Because these platforms shifted our reality, the reality of what we do in the world. Our expectations of the technology has radically shifted. We expect to get information in the palm of our hand. Unfortunately, our building industry and BIM is still somewhere stuck between number 1 and number 2 there. And this is bad. I love the periodic chart. This happened by accident. My presentation, I didn't know I was going to have a periodic chart up there, but it's perfect. So we need to go from bad to good. So bad, it was these old phones. You bought a phone, you put your information in it, and then when you wanted to buy a new phone, you threw away your information and you bought another phone. Today, if you lose your phone, you pick up another phone and you log into your information, right? That technology is already there. Imagine if the building industry can go there. And that's what we need to do because the industry is so complex, it's collapsing on itself. The technologies we're using and the processes we're using cannot sustain the capacity that we need to make these complex decisions. So let's apply these technologies the great technologies that are out there need to start connecting. We're still very much, a lot of great stuff happening, but it's a lot of islands. So these shared services of the satellite system shifted our world. Pokemon Go and VR is a common thing for everybody, but we're just starting to scratch the surface with the building industry. Imagine what we can do together to shift our industry. It's really up to us. We can't wait for the technologies to come to us. We have to show what the solution is. There's a lot of great knowledge and information out there. The bad part is that it's trapped in the wrong format, in analog format, and in BIMs that don't talk to each other. So even if you have a BIM, it's still not at this point where you can click on things and search wherever you want. Let's go from bad to good. So, Little BIM. How many know about Little BIM, Big BIM? Little BIM is about the project, the single software, the team that's surrounding all that. Very important stuff. Big BIM takes it to the rest of the world. How do we connect to the environment? How do we connect to energy and energy use? Portfolio information. It's not one or the other, it's both. But if you're only doing Little BIM, it's still bad. The opportunity is to turn that to good and think in terms of how do you expand the horizon and what we can do with that. So let's get to the topic of owners. We work with a lot of owners. As an architect, I started using them in 1993, and the opportunity that has opened up for me is owners are starting to come to us for helping us with their strategy about information and portfolio and the big picture. And you've seen a lot of presentations about this today. As you start understanding the information flow, new opportunities for services open up for you beyond the project. That's the big opportunity. So the owners say, this is Renee Tejan from VA, who I presented with a few months ago. Owners' rules, what we want you to do, are often written in a secret code only the initiated understand. They're delivered to us in formats like PDFs, outdated web information, analog documents that are not the right format. Imagine if you wanted to make an airline reservation and you got handed a paper document like that that said, here's a schedule of flights tomorrow. Or you had to download the PDF of all the flights from LAX and come back 2 weeks later and buy the flight. That's how we're working with our information in the industry today. It's very static, it's outdated, it's in the wrong format. Bad. So the project with VA was about taking the data that they already had and opening it up to the industry. We recommended to them, open up government data to the industry so we can plug into it and use it to do our design work, rather than us having to read through a bunch of documents and digest it into a format and then manually put it into BIM, billable hours, the wrong kind of billable hours, because we're spending time doing stuff that should be automated. So we are at a point right now where we have their data generating BIMs of requirements for a project, complex projects, 500,000 square foot, million square foot, 100,000 square foot, doesn't matter. It generates the first version of a BIM with the owner's data inside it that the architects and the consultants can work with. So what used to be a system where you would get a PDF file or an Excel file from their system, the Space and Equipment Planning System, SEPS, now is feeding directly into a format that feeds right into BIM. It generates Revit, ArchiCAD, SketchUp, and these tools are online, and if I have some time, I might even show a little bit of it live in a minute here. If you go to seps2bim.org, you can try this out. So that's good, that's a good thing. If we have good data from owners, then we can do our design work, we can be creative. And the owner is going to get standardized project data back to them that they can manage for the life cycle in a consistent format. It's all data. And it doesn't have to be complex. A lot of the misconceptions about BIM are that good BIM is very complex BIM. But as was presented earlier, the data, if you drive the data, you can have it in different formats and you can feed it into simple chairs or complex chairs, but the same data is driving to different formats. The tools have to be easy to use, easy to understand, and easy to develop against as a developer. As a builder of applications, you want a way to plug into it and create solutions. So the solution that we proposed to the VA was what's called a three-tiered architecture. You decouple the data from the application, you make it neutral, and then you drive it through rules or APIs into other applications. You can build new functionality along the top. These are how our apps on our phones work. If you need a new app, you throw that app away and you find another email app or another mapping app. The underlying data is still accessible to the end user. And the price of building apps has gone down because of that. You don't have to build the whole stack. In BIM, we're very used to putting our data in the BIM. There's still a lot of these presentations. We're building a BIM, we're putting all the data in the BIM. Then we need to figure out a way to get the data out of this BIM and put it into this other BIM. Still very important. That's where IFCs and all that other standards come in, and we use that as well too. But when you make the data neutral, then you can move it into any format you want. And you can build apps on top of that. You can build simple apps over the weekend. You can build complex apps. The data is owned by the owner of that particular data, and you're not trapping it in your application. And it can be many sources of data. Our phones and the internet is not one huge database. It's tons and tons of sources of data coming to us so we can build an Uber app. We don't really care where it comes from. We create value and functionality on top of this data, and because we're the domain experts about the building industry, that's an opportunity for us. So, the game changer here is, this is the first owner, I think, that has opened up their data to this level, just like the DoD satellite systems. And it's our opportunity to show what we can do with it. And app developers have started to plug into this. We had BIM objects, we had ArchiCAD, SketchUp, Atania, Codebook, TryWG. We have our own app too, it's called Onuma, but we started that, we kind of said, well, here's how you do it, and we'll teach you how to build your own functionality on top of that. The multiple applications connected from SEPS to BIM are starting to be developed. Some of them are 3D, some of them are not 3D. Again, it's not about 3D or 2D or whatever, it's about functionality, sitting on top of the data to do what you need to do. So let's talk a little bit about the next chapter here. I call it Breaking Bad. We need to break the bad: architecture, engineering, construction, owners, operators, occupants. The stovepipes need to be broken. That is our task, to turn it to good. There's such a huge opportunity here. The software developers are not going to solve it for us. We in this room that are willing to move there are going to be able to do this. 2 days ago, I was in Alexandria, Virginia, and this was the name of the day. It was a whole session that day called Breaking Bad Stovepipes. So going from bad to good, we did something called a BIM storm. This has been going on since 2008. This BIM storm is centered around airports and clinics and educational facilities. It doesn't matter what type of building type it is. The underlying DNA, whatever you call it, a small building, a small project, a huge project, an airport, train station, healthcare facility, the underlying DNA is the same. BIMstorm is free to join. Anybody can jump in. We get sponsors to support this. It's essentially a hackathon for architecture, engineering, planning, and software development. San Jose Airport submitted all their plans, and some of the workflows here were, what drives the need for space? In the airport, it's passengers and aircraft coming in. In the hospitals, it's patients. And in school, it's students or gatherings like this. We identified 14 scenarios. We're still working on them, so they're still open. The other day, on July 12th, we gathered to sample these scenarios and see how we can actually work together. So, for example, airlines arriving at the airport drive the need for space, drive the need for aircraft to park at that space, drive the need for standardization of requirements of space, drive the need for using standards and open standards, to create master plans, to do new construction, to do move management, to do renovation, to look at total cost of ownership, to manage risk, to manage facilities, to use technologies, people, and agreements, and look at the hooking to the environment. No single group or person knows all of this. But if we start plugging into each other and we respond to the owner's needs, collectively we're solving the wicked problem that is being done today in a bad way. It's incredibly inefficient. The owners are getting frustrated because we're not able to help them solve things. So if we look at this and say, how can we solve this? That's what we did with BIMstorm. So this was July 12th this week in DC, in Alexandria. Teams there in the morning were starting to look at the data. We created 14 scenarios. One of them was a master plan. 700,000 square foot expansion, renovate the building. These are based on real things that are happening at the airport. And we set up scenarios to say, what if we collected this requirement and worked with teams to solve this master plan, or to respond to the master plan, or used the VA SEPS to BIM engine, the engine that says, what do we need for space in a hospital? If you change the word healthcare to airports, there's no difference. In healthcare, you need exam rooms, waiting rooms, whatever. In airports, you need hold rooms. and you need spaces for aircraft to pull in, and you need furniture and equipment that fits inside those spaces. So these templates were built to rapidly iterate, and if we saw some great examples today of technologies that start to automate the data. Once it's in a data format, you can do amazing things. Millions of documents are really nothing. Documents are meaningless. You generate documents on the fly in seconds, right? That's where we need to go. And if we don't hit this head on, we're going to be automated out of existence. We need to be part of this game. That's the opportunity. So we went throughout the day. We even encouraged hand sketching. Hand sketching is still important because that person has a lot of knowledge about airports. We need them to interact and give us input on how you design an airport. We had teams offline. In fact, Ryan Gear in the back there and Young was here in LA, and they were working with us remotely there. And while we were doing this, we were documenting it. At the end of the day, we actually put it on Architect TV. You'll see a little bit later about that. Number 6 is about BIM and facility management. Once the data starts going through design and construction, the owners want to be able to manage their facilities over time. They want good information to look at the life cycle and say, when's that diesel generator going to fail? What's the total cost of ownership of the engineering decision to put that particular piece of equipment? And how do I, as an owner, decide where to spend millions of dollars to support the maintenance of these complex facilities? BIM Objects is also going to be part of this and giving us data of their building products and putting total cost of ownership inside the objects. So what you're seeing here is an open sandbox. It's a hackathon for architecture, engineering, and planning, and anybody can join. There's no cost to join. We just need participation. We love people that participate. You can come and watch too, but we really want that here's how we work on things. Why should we do this? Because then owners looking in on this sandbox say, wow, look at this team that can do amazing things. Can they do a real project for us? That's the objective. Don't tell us what you can do. Show us what you can do, and it generates potential value from that. We also went online and we look at data about flight arrivals. Yellow means here comes the plane. Red means here goes a plane going out, and that lounge is populated. You put this hour by hour, you can start seeing patterns of which part of the building is being used. Therefore, you can react and decide how to design for the future or how to renovate this building. So total cost of ownership, we're kind of familiar about total cost of ownership for cars. As you own a car and you fix it and things happen to it, you have to get oil changes for it, the total cost is not the initial cost of the car. We all are very much aware of that, but it doesn't seem like it's really sunk into the building industry very much. As we design these buildings for owners, we're not really taught a lot about, well, what's it cost to maintain and manage it over time. It's all data, and if you have good data, you can give good recommendations at the beginning of a project. So steps to BIM, the planning of a clinic. I think I might have a few minutes to show this slide. In fact, maybe I will. That's the best way to show this, to go live. Stepstobim.org. Anybody can try this. It's public. This is U.S. government data, publicly available on the web. I'm hitting a government server now. Developers can plug into the APIs in XML. I'm going to show you the shopping cart of this. This is the most simple part. You can actually generate a whole project too. But I can go in and say, well, I want to have dental exam rooms. There's some right there. I want one of these. It's like a shopping cart, basically. 2 of these. And let's go to the shopping cart. There's a shopping cart, how many spaces, how many pieces of equipment. Build a BIM of that. This is going to government database, getting their latest data about how they put hospitals together, pushing it into a BIM, into a database, pushing it into a SketchUp file, a Revit, an ArchiCAD, a COBE, an IFC, all on the fly. I just did 3 rooms, but imagine 500,000 square feet of this. It's millions of documents being generated on the fly. That's the trend line here. There's no reason to manually do this stuff anymore. The place we want to spend more time at is the actual value portion of this, which is the design and decision-making process with that. So if I go and get an email, click that email, it starts showing me what that BIM looks like, and it has a bunch of export buttons out there, and we put a freshness date to it. We're saying this is going to expire. If you come back to it a day later, it's going to be an old BIM. It's like going back to an airline schedule that you made yesterday and didn't buy the ticket. The price changes. Same concept, pretty simple. Okay, so we're using this process and teaching people how to do this in the BIM Storm for free. We have owners from unnamed agencies. They don't want to give their name, but these are big owners up at the top there. We had a TV station that at the end of the day, we had a 30-minute broadcast. So essentially, we went through a charrette in the middle of the day and then broadcast it out to the world at the end of the day. And then learn from that process. We're going to kind of rinse and repeat as we go along. How many of you know blockchain, Bitcoin? We're doing some testing, connecting blockchain to BIM. Agreements in a data-driven format. When you start making decisions, you can attach them to a blockchain, and you see who made that decision. Jump into the BIM Storm, you learn more about it. It's really fascinating stuff because it's about changing the way agreements and collaboration works in the world. This is something that's being looked at even by GSA and even the State Department, actually. They're looking at this technology to see how we can change things. So if you go to Architect TV, you'll see the broadcast. This happened in real time. We're basically doing a charrette workshop, gathering teams from around the world, and at the end of the day, we broadcast out. This is not the end of the workshop. We're going to go all the way to the end of December. So these 14 scenarios are going to be studied further from now until the end of the year. I think I'm pretty close on time. I have time for questions. Sorry, I went kind of quickly here. There's a lot more material to this. Can't cover it all here. The most important piece is nobody knows all this stuff. If you know where you plug into this, and you have an owner that's willing enough to take their data and put it online like this, and drive it into our design and construction process, it's up to us now to respond to it. And we're very excited about this because other owners, like we're talking to the State Department now. Yesterday I was at the FBI building for the first time. They're all saying, how could they all have this exact same problem? Just like the DoD satellites. They're all train wrecks. Every single building, design and construction process, there's so much waste that it's almost like easy pickings. How do we fix part of this? We can't do it as isolated teams. We can't do it with proprietary closed solutions. We need to plug into each other. If you do it as an island, that's kind of the past. That's an old model. You need to figure out how to create solutions that plug into each other and be fearless about it to get to this mobile technology type approach of how do you build apps. We'll take a few questions. Everything's clear.
Hey,
Yeah, go ahead.
you're talking a lot about owners and about the design process, the architecture process. How does and where do contractors fit into all this? Because there's generally a fairly large disconnect between, for instance, contract documents and what ends up actually getting built in the field. You touched a little bit on facilities management, but
Right.
there's a big chunk missing in the middle.
Yeah, we spend a lot of time with contractors. In fact, I was at the Construction Industry Institute presenting on Tuesday in Detroit. And the theme there was a quote from Bechtel that said, "Our house is on fire." The way that we construct, cost, and deliver buildings to capital projects to owners is on fire. This was Bechtel saying that. So the Construction Industry Institute is looking at doing similar things. It's interesting if you look at the different, like Georgia Tech and Texas A&M, UT, the Construction Institute, they're all trying to do similar things with a similar approach. How do we use agile ways to deliver projects, using lean and agile approaches to delivering cost and buildings back to owners? So yes, contractors and builders are a huge part of this. As an architect, I would say that the building industry, contractors are actually ahead of us in many ways in the use of technologies. They've been way ahead for a long time, and now architects are getting up there as well too, but we're still doing it as pockets. And something that concerns me sometimes, I see some of these presentations, I even hear the word proprietary. We've built this proprietary way to do this, to do facility management and sell it back to the owner. That's great, it's really cool, but it's not the way that we need to kind of collaborate fearlessly. So thanks for the question.
Hi, yeah, thanks for this
Right. The question is, how do we share and collaborate, and who's going to drive it, and how do we make, we have to make a living, obviously, if we give everything away. I think that's kind of part of your question. There's a fear of sharing that, who's going to drive the collaboration is the main question, right?
Yeah, my main question, I don't mind sharing. For instance, the software that I presented in the previous blog is actually out there for free. Everyone can just download it for free and use it. So I'm fully down with that. I'm mostly interested in who's going to drive this development.
Right.
If we're all going to be developing our own things, then it's still going to be difficult.
Right. Who's going to drive the development, and how are we going to get in line with each other if we're all developing our own things? I think in the U.S. and the technology that we've built here, too, that's basically the rest of the world is using now, too, I think, is this concept of the internet. The concept of the satellites is actually a perfect example. The Department of Defense is sharing satellites they use for defense to be used for the public, right? A large owner has the ability to drive change, and in fact, government started the internet pretty much, too, because of that. It's our task to tell the government owners that we pay taxes to help build this as part of the infrastructure. If they build an infrastructure and set some of the rules, then we can build functionality on top of that. And having a common platform underneath, and there are ways to do that on the web already, web services, and blockchain is part of that too. How do you collaborate and share financial transactions and still be safe on the web? The bad guys are using it too, but it's basically tools and processes like that that have already advanced pretty far outside of the building industry need to be brought into here. So in many ways, a lot of the answers already lie outside of what we typically are used to thinking about in BIM. The advantage that we have is that we understand the complexity of the building industry. Software developers do not know how buildings, facilities, and relationships all go together. So that is, in a way, is part of the development too, and how we could plug into that. It's not going to be solved overnight, but we have to do it in small increment modular pieces and just tackle it a piece at a time. And just like the internet is never done, but we're constantly using it, just developed and took off after that. So I think there's no reason to wait, in other words. We just have to tackle it head on. Thanks for your question. Yes?
The idea is to have on the postcard for all this room data sheets. How do you planning on having a consistency? Because upon saying that everybody is different and want to put them all together
I think your question is about the consistency in the room data sheets, right? Yeah, so the room data sheets that you saw were the initial idea of this owner, what they think they want into an exam room. It's not the final design. It's up to the designers to say, you're asking us for an exam room with these 30 pieces of equipment. In this case, we're going to design it in Revit and we're going to solve it. It's almost like them saying, here's a basic requirement. And before they were doing it like this, it's very simple stuff like the IDs of those pieces of equipment were not consistently communicated. So then as a designer, then we make up these numbers and there's no way to align things. So from a data perspective, it's very easy to solve that problem. How do we create consistency and track? And there are problems in the VA database. There certainly are a lot of problems in this owner's database. But until you see it, you can't point to it and say, this is the wrong piece of equipment. If you just see it in a list, there's all kinds of errors in the PDF files that are online even right now because they're PDFs from years ago. But just like an airline schedule, if you go and try and buy a seat on a plane, it gives you the layout of the plane. You can see a seat that's available to buy and you buy it. That's the kind of real time. The more we can get into this real-time connection to the owner's brain, then we can see what they're thinking about what they want in a hospital. And then we can react to it and say, here's our recommendation. I think we're out of time, but thank you very much. I'll be around.
So the resulting curved pieces now indicate where stiffeners can actually go. Any stiffeners that are no longer positioned on these curves will automatically be repositioned. The plane definition will be stored as a user attribute inside a point object in Rhino. Again, in a separate Grasshopper session, these planes, as derived from these points attributes, will be used to create curves to represent the shape of the stiffener object. These curves represent the nominal center line of the object at the top center. They do, however, at this point, not take into account the adjacent elements that they have to connect to. A grasshopper session uses filtering of geometry by attributes and some one to few closest geometry lookups to find the connecting elements. Trimming planes will be derived from these elements and stored as attributes again inside the wireframe curve. In the next session, these planes will be used to trim the actual curves. This is necessary for future steps where we need to create fabrication information and quantity takeoffs. As these trimmed curves are created in a new model, we still have access to the untrimmed curves from the previous step. Some processes may require the untrimmed curves instead of the trimmed ones. The stiffeners need to be mechanically fastened to the panel surface, and this is done by means of welded studs. The stud locations are defined in this stage and are represented by these green lines. A section profile needs to be oriented normal to the wireframe curve and panel surface. And also, whichever section profile that needs to be is also, again, stored as an attribute inside this wire. So Grasshopper already knows which section to take for each wire. So there is a plane that's also defined and saved as attribute on this wire. And then the section profiles are aligned on this plane. And then these section profiles are extruded along these wires. Then we bring in all these trimming planes that we saved as attributes and we create trimming boxes on them. And these trimming boxes for all stiffeners are now, again, stored in wireframes as attributes. And the actual stiffeners are trimmed with these boxes. And the result is a fully attributed solid representation of a stiffener object. So the same principles are applied to all of the panels, also for the nose. And this video illustrates the modeling process for all elements. So first we start with determining the panel joint locations based on rule sets and architectural intent. Then we trim away these joints in a separate stage. It's done automatically. Then these three-dimensional mean planes are used to set out this location of most of these grid lines. And then all the framing elements will be modeled based on extensive rule sets. Primary framing, secondary framing, and everything is attributed. And then reference curves are created for each cardinal point of each rail. And we again model these trim boxes to make sure that we can trim away all excess of geometry. Then these surfaces are created, and then we're going to model these stiffeners as I explained in the previous example. Extruded, trimmed. Then we come in with brackets, and they're related to the steel connections that we modeled in previous stages. Primary brackets and secondary brackets. And this is all done in an automated fashion. Each of these steps is a separate Grasshopper file that we run in sequence. And we have people working on all these different definitions in parallel, because everything is basically based off of the same wireframes and the same input models. But most of these processes were done in parallel by many people. And so ultimately we have one panel completely modeled. And this is just one panel, of course. And so after all these models are generated, and this is only one panel, but this project, our scope basically consisted of almost 24,000 panels. So you can kind of imagine the amount of work it would have been to do this manually. It would have probably taken until the year 2028 to do that. So after all these models are generated, we need to make sure the models are correct before we send them off for fabrication. So our colleagues in New York have developed a live link between Grasshopper and our finite element analysis software, Strand. And this is a bidirectional link that can have the frames analyzed for structural validity and bring the results back into the Grasshopper environment. And so by using this connection, we were able to validate all complex conditions under all load cases. And we also needed to make sure that the fabrication documents we were creating would actually result in the correct parts. So therefore we created Grasshopper scripts to interpret the information that we created from these models and use that information to recreate the parts in 3D and compare them to the parts that we modeled to make sure that everything would actually lead to the correct piece. So here you can see that we actually compare that recreated part against the model. And to make sure there are no obvious mishaps in the generated models, we would perform a visual checkup on each and every panel before we sent them out. And for this we have developed a routine that will create a snapshot of each panel from a convenient perspective. And this bulk of images can comfortably be flipped through by a handful of people who will track any issues in an online spreadsheet. When all modeling work is verified, the next step is to produce the fabrication documentation for all the parts. I will show the stiffener first. In order to efficiently communicate the fabrication data for each stiffener to the fabricator, we created a diagram with variable dimensions for each possible combination of variables. An accompanying Excel file provides the exact values for the variable dimensions for each individual part. And next I will show you how the fabrication documentation for the aluminum sheets is created. The sheets are CNC milled after they have been welded to a CNC milled template. The template files are provided by us as 3D models of single surfaces. And the position of all elements is determined by the studs that are welded to the aluminum sheets. The locations of these studs need to be CNC defined. Therefore, we have to provide the locations as coordinates. But for verification purposes, we also need to produce a dimension drawing for each sheet showing all stud locations relative to the sheet edges. So we take a few steps to find all these stud locations on the panel. And we add the locations to the provided CNC file. And the surfaces for the template are created automatically. The panel information is then in turn turned into a dimensioned 2D drawing that can be used to check all dimensions, as well as a 2D drawing to check all locations of the studs. So when all models are checked, all documents have been generated, and all parts have been fabricated, the panel needs to be assembled. All parts are labeled in the model, and an Excel file is created for each panel to describe which label refers to which part ID. And each labeled assembly will then be represented in a PDF that is accompanied by the generated Excel sheets. And this is what the assembly process looks like. And this process is performed for all parts and all panels on all members and all nodes in the entire project. Resulting in an output of roughly 350,000 fabrication drawings and 150,000 assembly drawings, representing roughly 1 million parts, unique parts, I must add to that. That is documented from a model consisting of over 3,000 Rhino models that were generated by over 400 Grasshopper definitions. The project is currently under construction, and the facade installation is nearly completed. And so this talk is also nearly completed. And I want to explain that this talk is not really about bragging about this project or about how many parts we did. It is actually really about proposing a new way of modeling geometry and modeling data, and step away from the fact that we need files and models to exchange information, And I hope that we can think about how we could maybe utilize the cloud and and data exchange rather than file exchange for future processes. Thank you for your attention. Yes, absolutely. It was also a painful process at times because we created the shop drawings in a parallel process. The shop drawings were approved by the architects, and then we made sure that all of our fabrication documentation was actually according to the shop drawings. So the modeling team was basically modeling off of the shop drawings. Okay, so the question is, how do we distribute the tasks among the team? And the other question is, can we actually reuse some of the portions of the graph? And so distributing the tasks is basically, in this case, not too big of a problem because the team on this job was actually very small. I can say there were only 4 people working on this job. And so it took us about 8 months to get all of this work done with only 4 people. So I would say that attests to the process, but also you can imagine that it's relatively straightforward to manage a team of only 4 people, myself included, to get all this work done. So we would have just a big schedule on the wall and everyone would be assigned tasks, and we would have online task management systems for that. In terms of reuse, absolutely. We would be able to reuse a lot of this knowledge on different projects because the process is very strict. It starts with an envelope model and you take it all the way to a detailed fabrication model. And so we only do facades, so that makes it a little bit easier because facades consist of panels and each panel needs to be fabricated. So the process is very similar, and we would set up routines to reference and filter and structure our data and output them with pre-specified attributes, and all that we can just reuse in different projects. It's just only the middle part of each definition that's a little bit different, which is actually dealing with creating the geometry. But the rest of it is pretty much already set up. We've got scripts running for setting up folder structures, we've got scripts for setting up the models, the model names, accompanying work sessions, accompanying script files, etc. Also, all that is also automated. Okay, so the question is, why are we storing all this information in a 3D model instead of in a database? And it's a great question. And I would really like to take it there. At the time we started devising this process, and that's already years ago, we actually started off with a database, but we realized it was for us quite hard to define geometry in a database. And at that time we decided we cannot store the geometry in the database, we will store the data in the geometry base, basically. Currently, we're of course rethinking this strategy. At that time, we just needed to get the job done, and this was a way to do it, and it was working. I would really like to think about ways, and John already just talked about a little bit, about finding like a common ground, like a platform or a communication language to exchange not just data but also geometry on a neutral level between platforms, maybe to begin with, and maybe in its own platform in the future that could be accessed by anyone. So yeah, I hope that answers your question. I really hope to get there, and people are working on it. People are working on defining geometry in a neutral format for the cloud.